This video is over exponential tables. If you would like to print this note-taking guide, you're welcome to do so, or you can take a picture, write your notes on paper, and then your assignment today is actually just submitting your notes along with any questions that you have on exponential tables. You can just write them in the comments. So let's go ahead and get started. Our goal today is I can identify if a table is linear, quadratic, or exponential. It's similar to our goal from yesterday, except for today we're just focusing on exponential tables rather than linear or quadratic ones. But let's review really quick. From yesterday, if we were looking at a linear function in a table, we know that we would have a constant first difference. That means the pattern of our y values, the first difference that we saw, would be the same. Quadratic functions have a constant second difference. That would mean the relationship between the first differences is the same. So first differences where we look at our y values, second difference we'd look at our first differences to see if they were constant. But with exponential functions, it's a little bit different. We're looking at something called ratios, which we'll get to in a second. But I always like to do this one separate just because it takes a little bit of extra division to do, if you will. But if you need a calculator, you can feel free to use your phone calculator for this because it is rather simple, or you can use the desmos.com/scientific calculator. So let's review exponential functions first. Below are just some characteristics of exponential functions. And whenever we look at an exponential equation, they're typically in the form of f of x equals a times b to the x power. Notice that here, to the x power, that's different than quadratic. Quadratic functions are to the second power. Exponential functions are to the x power. It's a good way to tell the difference. Over here, I've actually graphed 2 to the x power for you to look at, and we can look at that graph. It's got a nice J curve, all right? All exponential functions are J-shaped curves. And just to jump back to the equations, when you're in your equation, your A is your initial value or what you start with, and B is either your growth or your decay rate. So in this case, our function is increasing, so we know it's growing. If it was in reverse, if it was maybe in this direction, we know that it would be a decay, because as we read left to right, it is decreasing, whereas our red function, as we read left to right, it's increasing. So whenever you look at exponential functions, the pattern of the y values is a multiplication or division pattern. That's how we identify it. I should have made my blank longer. Exponential functions are the only functions in Algebra 1 that have an asymptote. And remember, an asymptote is that line that the function gets very, very close to, but never touches. So if we were to look at this function that we have here, our asymptote would be y equals 0, because it gets very, very close to y equals 0, but it never actually touches it. And the new item that we're learning today is that the y values, when you look at a table, have a constant ratio. Remember, a ratio is just a fraction. My I kind of overlapped with the T there. Let me rewrite that. A constant ratio. A ratio is just a comparison between two values. And in this case, we're going to be comparing the y values. So let's do 2 examples to get us started. So again, like I just said, our ratios are comparing the y values of the function. Not our first differences, not our second differences, our y values. So we've got 2 examples here to look at. Let's start with the first one. We've got x's and y's, and we're going to work on comparing those y values. So let's make another column, and we're going to title that ratio. Okay. So we're comparing one y value to the previous y value. So here we don't have a previous y value to compare it to, so we're just going to put a line through this one. The first ratio we're going to look at for here is 15, and we're going to divide that by the previous y value. So 15 divided by 5. 15 divided by 5 gives us a 3. Next one, my y value is 45. I'm going to divide that by the previous y value of 15. 45 divided by 15 is 3. All right, this is a good sign. My next y value is 135. My previous y value is 45. When I divide those, I get 3. Next, I have my y value of 405, and I divide that by my previous y value of 135. And when I do that, I get 3. So I notice that my ratio between my y values is all the same, which tells me that this is an exponential function. Let's try it with one more example, example 2. Here, I'm going to make my column for my ratio. And normally we could add a first difference, second difference, but today, again, we're just focusing on exponential ones. Tomorrow you'll have to kind of distinguish between them. So for here, I'm going to, again, look at my first y value. I don't have anything to compare it to, so I'm just going to put a dash through it. We could find it, but we just don't need to in this case. That's not what the question is asking. So for here, 10 is my y value, and I'm going to divide that by my previous y value. I'm making a comparison between y values. That's what a ratio is. 10 divided by 4 gives us 2.5. All right. 25, my next y value, divided by the previous y value of 10. 25 divided by 10 gives me 2.5. Next, I go to my y value of 62.5, and I divide it by my previous y value, which is 25, and I get 2.5 again. Again, a good sign. My next y value is 156.25, and when I divide that by 62.5, I get 2.5. Perfect. So if you notice, my ratios are all the same. So that implies this is an exponential function. So to round up this last sentence, whenever you're saying or determining what type of table you're looking at, linear, quadratic, or exponential, if you notice that your ratios are the same, you would say that these functions are exponential because the ratios are constant, is the word you use. The ratios are constant. Constant just meaning the same. So again, for your work session today, all you're doing is uploading a copy of your notes and any questions you have about how I did anything in these example problems.